with the FastPath, and now we finally have the necessary set of features about that FastPath. So we will talk about it. Let's start with the question. Has anyone of you before this have seen, on this picture? Have you seen this? One, okay, several. Okay, who understood it? Okay, so basically what it is, it's Routeros packet flow diagram, and it's the main reason why sometimes MikroTik router performance might be a little bit lower than, for example, D-links or linksys or so on. You plug linksys, you put a NAT on, it works wire speed. You do the same with MikroTik, and you get only half of the speed or something like that. So why is that? Well, it's very simple. MikroTik does very many things, and if we take a look how many things, we try to make this diagram. In one picture it was not possible, so that's why it's in 2 pictures and even more in 3 pictures. So just to clarify, you see boxes 1, 2, 3 here, so bridging, MPLS, and routing. These are exactly the same boxes, only zoomed in. And you see here are special type of boxes, pre-routing, post-routing, forward. Those are exactly the same boxes over here. So this is just a small way that allows you to indicate how many things, how many configuration does the packet have go through to actually go through Routeros. So, and this is why packet performed in the way as it did before. Just for to simplify all the things, we will call them the old way how the packet is processing, slow pass. So new way will be fast pass, and old way will be slow pass. So let's take a look just to illustrate how it works. So if we have simple bridging, so you just bridge traffic through, so the packet in this diagram goes like this. If we zoom in, we first check this bridge destination NAT. Has anyone of you here ever used the bridge destination NAT? It's a very specific feature, but it needs to be there. So use IP firewall feature, yes or no. Bridge decision, this is the only one that we're using 100%. So if you have a bridge, then you will have a bridge decision, and you will go there. So bridge filter forward, bridge source NAT, and so on. So lots of boxes that we need to travel through. If we talk about MPLS going this way, so through the second box. And MPLS is quite simple if you want to diagram it, a little bit more complicated to configure it, but MPLS decision and switch label, and that's it. And our favorite and most complicated is routing. So going through the last box. In here it looks quite simple. Pre-routing, routing decision, forward, post-routing. And if we zoom in, it's all these things in line over here that need to be checked for the simple routing. So that's why we implemented FastPath. FastPath implementation comes in stages. So first stage in a FastPath implementation was simply adding this feature to the driver. So if somebody asks you what FastPath is nothing more than an interface driver extension. So it's a driver feature, nothing more. So this driver feature allows you to receive, process, and send traffic without unnecessary processing. So in this case, you can talk directly to the specific Routeros process and skip all other processes. So 3 things that need to be needed to enable FastPath on this initial level. First, you need interface driver support. Then it should be allowed in configuration. It is allowed by default, so if you haven't disabled it, it's enabled. And then there shouldn't be some specific configurations in some specific facilities. So let's go one by one through these. So driver support. It's supported on all the newest hardware that we produce. So I will not go through, I just point out some things. First of all, how many ports does the 1100 have? Anyone have seen 1100 router board? 13, but as you can see, support is only from 1 to 11. It is just because ports 1 to 11 are directly connected to the CPU, but the Ethernet port 12 and 13 are connected through mini PCI. So FastPath support doesn't really make sense on these drivers, so these are not supported. We need direct connection to the CPU. Same thing goes for Ethernet 3 on 600 and 800 series. And there's one board missing. Who can say what board is missing here? 1200 is already quite an old board. So all the current, yes. From the current set, there is 850G X2, not here, for one simple reason. That board have IP security acceleration, which we cannot replicate with FastPath. So we had to choose either FastPath or IP security encryption acceleration. So that board is specifically for that purpose, and FastPath currently is into the to-do list, but not very high in to-do list. So that's the situation. And what about wireless? Wireless, you will get FastPath if you have wireless CM2 or rep package or legacy FastPath package. Yes, this is already legacy. It's already destroyed for version 6.36. So, second, how to make sure that your FastPath is enabled. So for routing, it's allow FastPath here, and you can check the status over here. If everything works in FastPath, you will have checkbox here, and some data going through. In the bridge, you have the same in the bridge settings, and the same thing. Checkbox and the option. What about configuration? So, this initial FastPath works very simply. It checks all these boxes if there are any configuration. So if you have no configuration in destination NAT, bridge destination NAT, bridge source NAT, bridge forwarding, so then FastPath will talk directly to your bridging decision. That's it. Traffic will go directly to the bridging decision and from the bridging decision over there, nothing more. If we talk about routing, then we also need to check if there's any configuration here. If no configuration, go to the FastPath. Of course, as we know, routing is a little bit complicated, so that's why we need to check all these boxes. What happens if you configure something? For example, if you add a simple masquerade rule, so there will be some configuration, and automatic FastPath, this initial FastPath level, will disable itself automatically. So it will just work when it's possible, and as soon as you add some configuration, it will automatically switch to the slow pass mode. Just to show you some results, so if you have simple bridging on 750G board, you get 700,000 packets per second with the small 64-byte packets. But as soon as you add some configuration in the bridge, for example, 25 bridge filter rules, performance will go down significantly. So FastPath is really saving some effort and adding some performance overhead over here. And if we go down to our biggest product, 72 core, as you can see, here is 119 million packets per second with a small packet. So basically, if for some reason you need a 10G switch and the only thing that you have in hand is CCR 72 core, just make a bridge, FastPath enabled, and it will go wire speed, almost to wire speed, even with small packets. So that's how FastPath versus something with configuration. So also when we added this feature, we needed to add some tools, some support for tools. For example, with amounts that you just saw, 72 core, we didn't have any way to test the device because it was so fast. So, and buying expensive testing equipment for, let's say, factory test where you need to test 20 units at the same time was too expensive. So we decided to make our own traffic generator. It's a tool that allows you to make your own streams and test device. And all those tables that all these numbers over here, you can take 2 more devices like these, run tests through, and you will get with traffic generator exactly the same numbers. So it's easy, repeatable, if you don't trust that table. Also, we had some issues about some clients connecting to the devices via MAC Winbox or MAC Telnet, so it's connecting to the device using MAC address instead of IP address. And till version 6.33, device driver will just go in this MAC Winbox mode and disable FastPath. After 6.33, we added support, so you can now use MAC Winbox and MAC Telnet without any issues. Also, there was a problem that FastPath was very good and really fast, but it also skipped traffic flow. So some of our customers were not able to charge their clients because they were not able to see the traffic. So they really asked us to add that feature. So we added traffic flow support for FastPath also. And the biggest and most significant feature added in recent history in Routeros is FastPath support for connection tracking. So FastPath plus connection tracking, and we have Fasttrack, or in this case, Fasttrack entries or Fasttrack flag in connection tracking table. So we give you the power to add this flag to any connection you like. So it's implemented as Fasttrack-connection action in firewall filter on Mangle. So if you go and configure your filter on Mangle, you can add this flag using this action. All the packets from the Fasttrack connections are allowed to travel in FastPath. So that means you can have firewall configuration and FastPath at the same time. So you can have your NAT and FastPath at the same time. This works only for IP version 4 TCP and UDP traffic. And you need to realize that as soon as you add that Fasttrack connection or Fasttrack flag, that traffic will become invisible for all other Routeros facilities. So invisible to queues and invisible to firewall. So all the next packets from those connections will go straight in the FastPath. That's why they will not be seen anywhere else. But as you know, connection tracking needs some packets to refresh some timeouts, or else connection will time out and something like that. So some packets periodically need to go the slow pathway to refresh those timeouts also. So And if we take a look at new connection tracking, you can see each entry, each connection tracking now have a lots of counters. Counter that shows what was the rate, how many bytes went through normal way, and how much traffic was fast-tracked through this connection. So basically what we did, we teached connection tracking to talk directly to FastPath in this case. So how it physically looks. I have here a simple rule that fast-track connections that have reached related and established packets. So basically, first packet that arrives to the firewall is connection state new. You check it through the firewall, and if it's all okay, all the next packets will be connection state established. So basically, most of the firewalls nowadays, except deep packet inspection, just usually are based on this connection state new checking. And before, you usually just accepted that traffic. Now you can fast track all the connections that have reached established and related state. And as you can see, in the firewall, this rule captured only 240 megabytes of traffic, but it resulted that in a fast track counter, it counted 15.1 gigabyte of traffic. So that means that this amount of traffic didn't have to go through your firewall. It went just directly from interface to the interface using FastPath. So what are the practical results about it? So let's take typical board 2011 with default configuration, so default home access point configuration. Before FastPath, this configuration was limited to 358 megabits per second throughput. So, and your CPU was going to 100%, and 44 of these percents were in the firewall load. So, device maxed out, you cannot squeeze anything out of it. Then just add that rule, and now you have 890 megabits per second. CPU load is not 100, and firewall CPU load is down to 6%. So exactly the same hardware, exactly the same firewall that checks connection state new all the way, blocks everything that might harm you, but it fast tracks all the established and related connections. So you lose nothing, but you get performance. Of course, now if you try to add simple queue, it will not work, because this traffic goes FastPath. You added a rule that allowed it go FastPath. That's why it will skip your simple queues if you have any. So you need to keep in mind. So as soon as we give you the decision what to fast track and what not to fast track, you need to consider all the downsides of that decision yourself. So this faster connection is very similar to MARC connection if you have done any firewalling in Routeros. And best practice rule is to follow this faster connection rule with identical accept rule. Because I told you already, some of the packets will need to go slow pathway. So that means that you need to capture them in the file, not drop them, or else some connection will just drop. Most popular fast track implementations so far, so that one I showed you already, this fast track all the connections that reached connection state established and related. Second most popular that we have seen is fast track some specific traffic to exclude it from the firewalling queues. For example, your VoIP traffic. You just fast track it so it goes straight through. And the third popular is just fast track your local connection. So you have DMZ servers, you fast track all the local traffic, and and all the public traffic goes through the firewall as usual. So to help you to remember that some of the traffic is not captured by the firewall, because in system administrators' world, it's a worse disaster when you see the traffic comes in the interface and you don't see it in the firewall. Yeah, that means one big disaster. That's why we tried to help you, and we added a special dummy rule, which is not actually a rule, it's just a counter, just to show you and indicate that you have a fast track enabled, and that this traffic that's captured by fast track is not going through your rules. But we got very mixed replies from our customers. Some of them loved the feature, some of them hated. So currently we don't know what to do. So again, this is a visual information only. It's not actual rule. And this this rule will show up as soon as you have at least one connection tracking entry in your connection tracking list. And it will remain there until the last fast track connection times out. So it's not just like when you enable a rule, it appears. When you disable a rule, it disappears. No, it will wait until all the connections with the fast track flag will finish. So, and it might be possible that in the future we will add similar rules to the simple queues, because on average we get 3-4 mails a day from customers saying that my simple queues doesn't work anymore. And of course, even without looking into configuration, we can ask, okay, did you enable fast track? Yes, I did. So maybe we need to add that rule also. So next important thing to understand is a half FastPath. So we cannot check, okay, let's put it this way. We do not check if the FastPath is possible all the way, because checking itself is slow. We just assume that FastPath is available until it's not. So when packet arrives to the interface that have FastPath support, it arrives the FastPath way, and if it finds some configuration where it needs to slow down, it will just go the slow pathway. But if your interface doesn't support FastPath and packet arrives in a slow pathway, there's no way for packet to speed up and get into the FastPath. So it's very important so that on the receiving end, you receive your packets in the FastPath mode, then it can travel through the whole router in the FastPath. So that's why we needed to add some support for logical interfaces. So first, that we added bridge for routing purposes, because you use bridge interface when you want to route from bridge interface to the public interface, another way around. So it's for routing purposes, bridge interface. VLAN interfaces, VRRP, bondings, but only for receive. Tunnels were added in 6.33. And one of the most important additions was in 6.35. It was PPPoE client and L2TP. So, and if we combine these two features, you know that that means that also LNS can be FastPathed if you configure it on MikroTik. So, one important and very important things. This FastPath thing doesn't apply to encrypted traffic and fragmented traffic. FastPath doesn't go together with fragments, and FastPath doesn't go together with encryption. So if you need to decrypt the traffic, it will go the slow path way anyway, and if you arrive the fragments need to be assembled, so it needs to drop down to the slow pathway also. So you need to really check your network for fragmentation and eliminate it, send smaller packets, change MSS or something like that to ensure that FastPath work properly. So basically what we did with these logical interfaces, now FastPath can go through here also. So that means that the whole diagram now can be FastPath and whole router can be crossed in the FastPath. So just to show you some changes, here we have PPPoE single tunnel through 10G interface from one CCR 1036 to another CCR 36. So if we go to the good old 6.7 version, we were limited just to 300,000 packets per second if we talk about 64-byte packets on single tunnel. More was not possible. Then we optimized some drivers for PPPoE, and we got up to 5.5 million packets per second through this single tunnel. And now, latest optimization, we added FastPath support for PPPoE client, and we got up to 26 million packets per second. So, and of course, most of you, you use connection tracking. So we can see the numbers here. So when you use connection tracking, instead of FastPath, you use Fasttrack. And as you can see, difference is almost 4 times between these when the Fasttrack is enabled and where it's not. Of course, again, as you can see, there's no big packets here, no 1500s, because 1500s will be fragmented when going through PPPoE. So no FastPath for those, that's why that column is missing. So what about tunnels? So each tunnel now have allow FastPath option that you can enable or disable yourself. Again, third time, fragmentation and encryption doesn't work. But as soon as you enable your allow FastPath checkbox, you need to understand that this traffic will become invisible to all the other Routeros facilities. It will skip firewall, it will skip queues, but it will go the FastPath way through your device. So, but always prepare your firewall. If something happens and you receive some fragment or something, this tunnel will jump back to the slow pass, and your firewall need to be prepared for that. So here you have exactly the same setup, but this time I run L2TP performance comparison. So as you can see, we got in the last step from 3.7 to 19.6 million packets per second over single tunnel. And if you use connection tracking, now and with Fasttrack, the difference is 3.5 times faster. So if we take a real setup, so this is home AP setup, but your ISP giving you connection via PPPoE client. So we are running 388 megabytes per second, 99% CPU, and firewall is 55%, and load in total is 99. And device is maxed out. We enable Fasttrack-connection, and you can see the load is still 9095, but traffic amount is already 887, which together with overhead of PPPoE, which means that it's running gigabit wire speed on this particular link. So this is just what changes when we added PPPoE client FastPath support in Routeros. One of the last things that you need to also know is that interface queue, there's only one interface queue that supports FastPath, and it's called only hardware queue. If you have any other, traffic will drop out of FastPath and go the last step in the slow pass way. So it's a last step, impact will be minimal, But still, if you want a pure FastPath through all your device, switch to this one. Okay, that was the theoretical part. Let's go to the practical part. I have 4 tasks for you. After I explain each setup, I want you to decide if FastPath is possible or not possible. So I will ask you the question. So we have a setup. We receive packet over IP-IP tunnel, which runs on either one, and goes out on either 2. So arrives as a tunnel, IP-IP1 gets out of the tunnel and goes through. Both interfaces have FastPath support, and on IP-IP tunnel, we enabled allow FastPath settings. We also have IP forwarding FastPath allowed. We have ICMP traffic, and we have NAT. So, is FastPath possible? Who thinks yes? Okay, who thinks no? Why? Not because of NAT rule. Because it's ICMP traffic. So NAT rule indicates that you need to have fast track. And fast track works only with UDP and TCP. So this is ICMP, and together with NAT, it will not be in FastPath mode. Okay, task number 2. Exactly the same situation, same setup, but the packet travels back, so from either 2 and goes out from IP-IP tunnel. Again, everything is enabled. This time we have TCP Fasttrack-connection, and we have simple queues. Who thinks that FastPath will work? Okay, who thinks that it will not work? So the correct answer, it will work. But your simple queues will not see that traffic. So, because this is a fast track connection, that means that this connection will skip all the Routeros configurations. So it doesn't matter if you have simple queues or don't have simple queues. It will just go through, and simple queues will not be able to see that. So, example number 3. We have local bridge. From one of the ports, packet arrives, and it goes out through PPPoE on either one interface. We have either 1 and either 2 FastPath support. We enabled IP forwarding allowed, and we have IP version 6 TCP connection. So who thinks that FastPath will work? 1. Okay, 2. Who thinks that it will not work? Why? IP version 6 is currently not supported. It is in our to-do list, but at this point, it's not supported. So correct answer, in this setup, it will not work. And last example, exactly the same setup, only packet travels other way around. So it arrives from PPPoE on either one, and it leaves through bridge port either 2. So we have either 1, either out, either 2 FastPath support. We have IP forwarding FastPath support, and we have fast-tracked TCP connection. Okay, who thinks that this setup will work in FastPath? Good. And it will work only if you use version 6.35 or younger. Because support for PPPoE was added only in 6.35. So just to summarize, FastPath is a feature that allows you to reduce your CPU load in specific configurations. It's not a global savior of all your problems. It doesn't mean that you just enable it and everything is better. In some specific configurations it is, but not in all. So basically you trade some Routeros functionality for performance. Maybe you don't use that Routeros functionality. So maybe trade is only beneficial for you. Next thing, and the last time, just to repeat, packet fragments. Don't work with FastPath, because if the traffic received as a fragment, we need to reassemble it. So plan your MTU and MSS very carefully. And the main thing is, FastPath need to be an interface driver. So we need to write interface drivers and add FastPath feature there. So please don't ask to add FastPath, enable FastPath for all x86 drivers. We are using Linux kernel drivers there. We are not about to rewrite them all. So FastPath will not be possible for x86, but it will be possible for all our hardware that's coming out. So FastPath is one of the main features that will be added to all MikroTik hardware that's coming out. Okay, that's all for me. Questions? Yeah, we are thinking about virtualization drivers because there are only few of them. So currently there are no, but we are thinking about it. Yes? Well, PPTP, as you all know, are quite historic event already. It's not secure, so it took 45 minutes to crack, if I'm not mistaken, when I read. So why don't you use L2TP instead, which already have FastPath? So now L2TP have one more benefit over PPTP. It's a FastPath support also. Okay. No more hands. Okay, thank you. If you have more questions, I will be there. Just ask me.